last few lectures we are discussing about the different counting techniques, and today we will start the combinatorics, which again is a counting techniques and a special type of counting techniques that we will cover under this lecture. So, combinatorics is normally concerned with the arrangement. Arrangement of a set into patterns satisfying some rules. So, I can write that in general it is concerned with the arrangement of a set into patterns and normally satisfying some of the rules. Now, normally we have two general types of arrangement or the type of problems we handle. One we call that existence of arrangement, that two types in general, two types of arrangement we consider. One is called the existence of arrangement. See, when we are concerned with some or we want to make some arrangement satisfying some property. So, first thing is whether at all it is possible or not, that means whether the arrangement exists. Now, if it exists, then under what condition or what are the necessary and sufficient condition that the arrangement should exist. So, this is called the existence of arrangement. So, in short we can write that it is about the whether such an arrangement is possible. And this satisfying rule then tells under or what are the sufficient, what is the sufficient condition, necessary and sufficient condition that the arrangement exists. So, that is why it is existence of arrangement. Another type of combinatorics problem we call enumeration or classification of arrangement. So, if the arrangement exists, then normally many different ways we can get this arrangement. Now, we have to or sometimes we may want to know that which one is the best possible way that we get the arrangement, then we call this is the enumeration. So, we can write that if some arrangement is possible, there may be several ways that we can get this thing, several ways. Then what is the best possible way, or what are the total number of ways, or what are the total number of ways we can or different ways we get the arrangement. Now, normally most of the arrangement problems that or we can divide into mainly two different ways that we make the arrangement. So, what are the two different ways? That one is the count the number of ordered arrangements or sometimes we call the selection. So, that is also ordered. So, ordered selection. Now, these also, so these ordered arrangements or ordered selections that we can do in two different ways. That means, we are selecting some objects from a set of objects, and this set can be of two different types. What are those type? One is that without repeating any objects, other is we consider repetition. That means, with repetition of objects similarly, that the another type that we can write the count the number of unordered arrangements or unordered selections of objects, and from the set that which have the same property either without repeating any objects or with repetition. With repetition of objects. Now, normally these arrangements of or selections in which order is taken into consideration. That means, here this first case, that order, it is a ordered arrangement, that means order is considered, and order is considered, and this type of arrangement we call permutation. So, where order is considered, that means the first case we call this is permutation. And the second type, see, this is that unordered arrangements or unordered selections. So, here order is irrelevant. So, second here order is irrelevant, and we take this is as a, we define this thing as a combinations. So, normally we arrangement either ordered or unordered, and the problems that we, or the counting problems that we will be handling, that either this ordering considering the order of the arrangements, or we can ignore the order, then it is called the permutation and combination. So, another point, that what we have seen, that both the cases, whether it is permutation or whether it is combination, we can do two ways. That means, it is either it is without repeating any objects or with repetition, both the cases, and that we take a set, we can define a set or a multi-set. So, now we know that say it is a set of say 4 elements ABCD. Normally, these are distinct elements. So, these ABCD we take for our, these are distinct elements. Now, we can take this type of set, say where this A is appearing more than 1. Say I have 2A, say I have 1B, I have 3C and say 4D. Then we define this type of set as the multi-set. And same set we can represent like that. Here A appears twice, so I can give the 2 numbers of A, 1 number of B element, C type of elements, that 3C and 4D. So, if I write S, so here S is a set of 10 elements, where A appears 2 times like that, B 1 time and so on. Now, we will also consider the permutation of multi-set and the permutation of combination of multi-set. So, we will also consider the permutation and combination of multiset. So, first we see the permutation of sets. Okay. Before we give the definition, first we see one simple example. Okay. I take a counting example. Say how many odd numbers are there between 1000 and say 999. So, this is a simple counting technique. Now, without considering any formula etc., how we can solve this? See, there are, I have 4 positions, since it is a 4 digit number. So, it is a 4 digit number, all numbers are 4 digit. So, it has, there are 4 places, say I have unit place, 10, 100 and thousands place. Okay. So, since it is odd number, so this unit place number can be only 1, 3, 5, 7 or 9. So, since it is odd number, so first we see that there are 5 different ways the unit places can be there. So, I take the unit place, numbers can be 5 ways. Now, if I consider that there will be no repetition, that means each number appears, each digit, say restriction, what I earlier mentioned that some property is satisfying some property. Now, say I am giving some restriction that each digit appears 1, each digit. Now, what will happen? That unit place, that means then one odd number that I have given, that among 1, 3, 5, 7, 9, we have to neglect that thing, and then these 1000 numbers, they can be, these 1000 places number can be only 1 to 9, because 0 cannot be there. But these 100 place numbers and tens number, they can be anything from 0 to 9, they can be 0 to 9, they can be 0, 1, 2, 3 up to any number from 9. So, I can put that 1000, that number I have already taken in unit place, that I have to discard from 1 to 9. So, there will be some 1000 places, will be 1000 places place, I have 8 ways I can give this. Now, then I have to consider either or 100 place, then I have to neglect from 0 to 9 there are 10, there will be 10 digits, and then already I have considered one for unit and one for 1000 since I have a restriction or these are the property to be maintained. So, I can put that 8 ways, 2 since there are 10, 2 I have neglected. Then for 10 places there are 7 ways. So, what are the result that I can get is 5 into 8 into 8 into 7, and these are the different way I can meet this number. See, I do not know, I have not used any formula, but this is something called counting techniques, and some ordering is there and also some property to be maintained here. So, how we can make this thing as a permutation? Okay. First I give that how, what is the idea or how we frame the permutation of numbers. So, I write let r be a positive integer. Then by r permutation of a set S of n elements, set of n elements is an ordered arrangement. Earlier we have mentioned that thing, that permutation is an ordered arrangement of R of the n elements. So, if I take say example, let the set S is a 3 element set ABC. Now, what are the different ways I can take? Say if it is a one permutation, that means how many ways I can take one element. So, there will be 3 one permutation, I can tell there will be 3 one permutation. What are those? That A, B or C. Then how many are 2 permutations? That means from the 3 element set I can take 2 elements at a time. That means, and some it is ordered arrangement. So, I can take ABC. So, I can take ordered AB, I can take BC, I can take CA. Now, since it is ordered, I can take in this direction CB, then BA, then AC. So, there are 6 2 permutations, and there can be 3 permutations also, 3 permutations also. Then I can take from a 3 element set 3 permutations is ABC, since it is ordered, BCA, CAB, and again some ordering can be different, CBA, then BAC, then ACB. So, again there are 6 3 permutations. Okay. And no 4 permutation is possible, no 4 permutation, since 4 is greater than 3 here it is a 3 element set, okay. Or I can write that in this case r greater than n, okay. So, now we define, normally the permutation we define this R permutation of n element set we define as a P n r. So, P n r is the number of R permutation of a n element set. If r greater than n, then P n r equal to 0, then we can easily I can write that P n 1 equal to n, because one element each time. So, for that example we have seen that P 3 1, 3 element set 1 permutation, that is 3, P 3 2, 2 permutation, that is 6, again P 3 3, that is 6. So, now I can give the theorem. For n and r positive integers with r less than n, we can write the in r permutation of n element set, that P n r is n into n minus 1 into n minus 2 up to n minus r plus 1. Now, how we can prove? The proof is the way, the example we have done. Say, choose R permutation from n elements. So, as if I have that R places. So, for the first place I can write the first, I can take n different ways, I can choose the n different ways, I can choose my object. Then it is already it is one is chosen. So, for the second I can take n minus ways, for third it is n minus 2, because already 2 have chosen. So, in this way the R element, the rth one, I can take n minus r minus 1 ways. So, by multiplication principle I can tell that my that is defined as P n r, this is n into n minus 1, n minus 2 into n minus r plus 1. The exactly the same, the simple example that we have done from that, how many numbers we can get from 1000 to 9999. So, now we can write in this way, this is n into n minus 1, n minus 2, n minus r plus 1, and I can multiply that n minus r, then n minus r minus 1 up to 3 to 1. Then I divide this number by this, that n minus r, what I introduced there, n minus r minus 1 into 3 into 2 into 1. So, this is the from the definition, the numerator is nothing but my factorial n, and the denominator is factorial n minus r, because n into up, we can multiply n into n minus 1 up to 1. So, what I get, my PNR, I get my, I write, so I get my PNR is n factorial divided by n minus r factorial. What earlier, normally we know this is the permutation rule. So, for simple set we get, this is my permutation, and if P n 0, I can write always this is 1, and P n n is n factorial. Now, if I quickly see one example, that what is the number of ways to order 26 letters of the alphabet so that no two vowels, that A, E, I, O, U occur consecutively. So, I have I can write that this is nothing but I have 5 vowels. So, I have 5 vowels and 21 consonants. So, 21 consonants I can take for consonants, I can place 21 factorial ways, and vowels, since this is the restriction for vowels, that no two vowels occur consecutively. So, as if these 21 consonants, if I place, say these are the consonants, say 21. So, as if these are my black are my places of vowels. So, there are 22 places for vowels. So, 5 vowels I can put in 22 places. So, I can write these are my consonants, and just now the formula we read. So, vowels we can put that P 22 5, because I have 22 positions and 5 vowels I have to put there. So, this is 22 factorial by 22 minus 5 factorial. So, if I continue, then my total number should be 21 factorial into 22 factorial divided by 17 factorial. So, this will be this is my result. So, instead of manual counting, now the permutation formula I can use to solve this type of problem. So, it is very easy way that some difficult problems accounting problems, when the ordered arrangements are considered, we can use permutation formula to solve those problems.